We could probably just leave that up there and have a discussion. Limited panel, as the name suggests. We have got a full suite of instruments. Why may some of our instruments have failed, do you think? What might have happened? Students should have some idea, eh? So we need to learn to fly with partial instrumentation. Electrical problems, instrument problems are not that uncommon. They're not common, but they're not uncommon. We certainly need to be ready for them. What might happen if you haven't got your instruments and you're in a cloud?
You're going to be a bit stuck.
So yeah. And if we didn't have an artificial horizon as a standby instrument, I'd ask, what would you do if you had no artificial horizon? How would you know if the winds were level? It'd be a whole lot different to G1000 limited panel, which is actually more comprehensive than some GA aircraft on full panel. But not all GA aircraft have an AI. So what might happen? Blogs will tell you you might lose control, you might lead them to the answer. We don't want to lose control in cloud, so let's learn this. Yeah. So why might it happen in the DA40? And you might talk a little bit about the one that we see all the time, the data path, the red X's, discussion around screen failure, maybe a little bit of reversionary mode, but what about if our alternator failed and our battery was sick? Worst case scenario, you're flying for a while and your battery goes flat as well. No alternator, no battery. So now we've got no electrics. What are you looking at on your pitot static when you do your pre-flight? Why? What can go wrong with that? And what's the consequences of, say, a blocked static? What instruments might that affect? So we're just doing a quick overview at this stage, a little discussion about what might go wrong. Not too extensive, I wouldn't think. Okay, so hopefully there's no poster around. We've got a PFD, we've got an MFD. Let's assume we've lost both screens. So what standby instruments are available to us? Blogs. Hopefully, it'll tell you can say there's 4, and then you can bring up the slide. So we're learning to fly solely on these. That's what we have defined limited panel in the fluid. Same skills as full panel instrument flying, just less instruments. And we interpret them slightly differently. Slightly different scan. Let's do performance and control instruments. Traditional instruments tend to lag more than some of the stuff you're used to. So it's important we make small inputs. So if you were flying straight and level and that's the instrument you had, how do you reckon your scan might go? What do you want to look at primarily in straight and level, do you think? What's blogs likely to say? He's going to guess maybe. Or straight and level, probably the altimeter. Well, actually, it's all about attitude, blogs. Everything is about attitude. If your attitude's correct, everything else will fall into place. So here's a scan for you. Notice how every time we look at an instrument, the very next one we look at is the attitude indicator. That's because attitude is so important. So look away, back to the AI. Look away, back to the AI. Hold your attitude and everything else in your piloting world will be fine and dandy. We're only glancing at the other instruments to check our performance, really. It's all about attitudes. It's actually a common fault with students. They'll get busy looking at their nav log, looking at random instruments, basically looking away from the AI too long. So very early, regardless of limited panel or full panel, we need to train them.
Hi, can you check this wall controller if that's alright? The air conditioning?
Oh, okay, well, what's that entail?
Oh no, just 2 seconds, I'm just checking to make sure the filters have been reset.
Oh, okay.
Thank you.
Cheers.
Yeah.
So with your pattern, sometimes I'll just say AI, or I'll point to it, or I'll say things like, if you look away from the AI, I want your eyes back on the AI within 3 seconds. So really emphasise AI and attitude. So the last thing we want to happen is a standby instruments failing, so we need to really look after them. We don't just ignore them until we need them, we monitor them, we're very careful with our pre-flight. So these instruments work on picostatic. So what's our pre-flight consideration? Oh, you've got to make sure the little holes okay. Oh yeah, how do you clear the hole out? You're blowing it? Ah, no, we didn't learn to do that, good. Okay, what if it's suddenly blocked up when we were flying? And then we were climbing. How would the altimeter behave? So a few basic questions like that. What would happen to the airspeed if the pitot is suddenly blocked up with ice? Should we say halfway down the takeoff roll? What would you expect it to do? Just a couple of basic scenarios to get them thinking about the system and the need to look after them. It's a bit of a funny PowerPoint, this one, it's not advancing. Is this about to crash?
Probably. If you look at the timer and it's frozen, then yeah, it's probably crashed. I've just hit the forward with the mouse and it's thinking. Is this what it does in here? Yeah.
Do I need to push escape?
Yeah, and reset the PowerPoint usually. Yep.
Not responding, close the program. says Michael Horrocks in the bar, so we'll blame him.
Sorry, team.
I apologise on behalf of the messy IT department. Okay. Yeah, talk about the alternate static source, make sure they've got an understanding of that. And how failures start happening once. For example, if you had an electrical failure and you needed pitot heat, it ain't going to work. So now your electrical failure has given you multiple instrument failures. What about the AI? Is that driven? Well, how does that work? What drives it? Suction pump? So just trying to build a bit of an understanding of the systems. What's going to happen to it if the battery or the electrics fail? They might even know the answer, what they need to do. We've done the ground course. So a lot of this stuff is, they should have some of this knowledge so they can help with the discussion. Fill in any gaps. What's important we check in the pre-flight? What do we need to check on the compass? What are we looking at when we look at the emergency battery switch? Just make sure they're aware of what they're looking at. It's part of our SOPs anyway. We'll talk about small inputs. Human factors, taxi checks. What are your taxi checks blogs? Good. So do you remember from full panel, if you become disoriented, what do you believe? Do you believe how it feels, or do you believe something else? And blogs will respond. Believe your instruments, because they would have had that in. They would have had the full panel one first, eh? Scans are best if they're practiced and they're disciplined. You need to develop a scanning technique and yeah. So if you were out solo in the Solomon training area, or heaven forbid, you ended up in a cloud, not that I'm saying I think you're going to do that, but it has happened. What would you do? So now we discuss a scenario. I need to keep control of the aeroplane, or I need to believe in what oh yeah. Would you talk to anyone? How would that radio call go? What would you ask for? What would you say? There's a speaker note here. If we lose PFD, MFD COM1 is automatically on 1215, even if there's no screens, as long as there's power somewhere, which I do remember from the ground course. It's in there. So that's all theory, and now we're on to the that we've all been waiting for. So the objective of the lesson is to have a technique to recover from an unusual attitude. So it's an attitude that we don't usually encounter, and it's probably one we end up in by surprise for whatever reason. So what sort of reasons would we end up in an unusual attitude? So I'm talking about the speeds climbing or reducing. We're in a funny attitude, something other than straight and level, or the climb or the descent that we were supposed to be doing. How could that happen? What's a student likely to say? Oh, I wasn't scanning. What might happen if you look down at your nav for too long? Oh, distraction. So that's the reason. So let's define it a bit further. So anything more than a bank angle of 30. That doesn't mean a steep turn's an unusual attitude, because you're trying to do it. That's what you intended to do, and you're under control. But nose up in the air, speed reducing. What's going to happen if we stay there? That's not usual, it's unusual. What happens if you don't use enough back pressure in your steep turn, or you get too steep? Do you remember? Oh yeah, I spiraled out of the bottom of one the other day, that's right. So the spiral dive, we've already touched on this one a little bit when they did steep turns, if they've done it yet. The big thing is that it's not intended, like a steep turn is intended. If you end up in a steep turn inadvertently, then that's probably an unusual attitude, because you're not trying to do a steep turn. So, okay, that's easy enough to define. Physiological sensations. There might be some loading, positive or negative. The signals you're getting from your ears might contradict other inputs, or what the instruments are indicating might not agree with what you are feeling. So there's some cues there. How do we recover? Well, first of all, your instructor is going to mishandle the aeroplane and put it in an unusual attitude. And you'll have your eyes closed, and when you open your eyes, you're going to have to figure out what's going on and fix it. So how do we do that? You need to. First of all, before you can recover, you're going to need to know what it's doing, eh? And if you're in cloud, you're not going to practice in cloud, you'll be under the hood. But how do you recognise what it's doing? What's Blog's going to say? Or from the instruments. So when we know what it's doing, we have to get it back to a normal flight attitude. And the one we're going to get it back to is straight and level. And then we'll have a bit of a tidy up and figure out what made it happen so it doesn't happen again. So it's a little bit of a checklist that we're going to commit to memory. First thing we'll ask ourselves, what's the nose doing? How do we get that? Which instrument do we look at? Oh, AI. We also ask ourselves, do we have an angular bank? How do we get that information? AI. So blogs, what's the first instrument we need to look at? AI. We need to consider our speed and what to do with the power as well. We need to get the wings level. What's the order? Well, it depends. If the nose is high, okay, you look at the AI, the nose is high. And we have a low decreasing airspeed. What's the first thing to fix, do you think? What's going to happen if our speed decreases any further? So what would you want to do first thing? Easiest way to fix that?
Lower the nose.
Get the nose down.
Yeah, we control speed with elevator and attitude, don't we? So we'll lower the nose. Don't even worry about the wings just yet. Once we get the nose to the horizon, we can roll the wings level. Sorry. Should be for you fellas flying, eh? And then we'll adjust our power to set it up and straight and level, retrim, etc. Okay, so again, can you talk me through what do we do first? Okay, and the next one is the nose low recovery. I suppose depending on whether the student's done steep turns or not, where does it fit on the syllabus? Do you know? Have they done steep turns?
After steep turns.
So they have done steep turns. So how you doing your steep turn? Got too steep? There we go, we're in that attitude. How do you recover? You should already know this, eh? So we're in the situation, and they might have just told you, so let's just recap it. We've got a high increasing airspeed. Do we drive our car down the hill at full throttle? No, it'd just make us speed up rapidly, wouldn't it? So let's close the throttle. Go back to that one. What's the next problem? The attitude. How do you fix the attitude depending on whether you've done steep turns? We've got two things to fix. What are they?
All the wings they do.
Okay. So you're a good student. You remember from your steep turns. Yep. Don't forget to do it in balance. Now that the wings are level, we can raise the nose to the horizon, reset the power. I'll just leave it there, put the model down, rip through human factors, airmanship. We talked about it earlier, trust your instruments. Look out, your instructor will have a look out for you because you'll be under the hood. If we're doing these exercises and you're under the hood and your instructor's having problems sighting traffic, you can come out from under the hood and help with the lookout. We'll interrupt the lesson. What's the scan again on limited panel? Blogs, do you remember? If not, you can tidy up the order. And just like stalling, we want an automatic response. So, blogs, how do you recover from a stall quickly?
Check forward, full power, reason,
Too slow. Okay, you were asleep. So you got that automatic response for stalling. We need to do the same thing with these unusual attitudes. So you're not caught with your pants down. If you end up in one, you can go, bang, I know what to do. Recover in the correct order. Smooth control input, so we don't overload the aeroplane to a high speed stall or make the situation worse. Just like stalling, we need a fine pitch propeller. If we're slow, if we're going to use full power. And just like stalling where we have high and low power settings, we're going to monitor our T's and P's. And then I'll ask the question, what's VA? And they'll give me a number and I'll say, yeah, but what does VA actually mean? So we can talk about what VA is and why we have it. And just reinforce that last point. So now it's finished. What's the next logical stage now finished with the PowerPoint? Blogs. Oh, unusual attitude. Where do you look first?
Yeah.
AI, good. What are you looking for?
Nose attitude and move back.
Okay, your nose is high and back. What do you look at next?
Speed.
About half a second after the AI. Maybe not even that long. Okay, speed is low and decreasing. What do you do?
Full power, lower the nose. And roll.
And then,
Return to normal flight.
very good. Readjust your power.
Yeah.
And it might take more than one go, obviously, so they're not all going to have that answer up their sleeves straight away. Quickly, blogs. What am I looking at?
Nose load.
AI.
AI.
That's right, AI. Yep, nose is low, it's bang. Next,
Airspeed increasing.
high increasing, yeah. First job.
Roll wings little.
And we're still flying towards the ground flat out.
You want to reduce the power?
Oh, closed throttle, wings level. So, yeah, run some of these scenarios. If you can get it wrong when you're half asleep, imagine how some of the students are going to respond. Mix it up. Okay, don't know what we're looking at now, just instruments. You look at the AI, wings are level and the nose is high. What do you do next? Look at the airspeed as you're lowering the nose. Yeah. So see how you build a bit in there. For you guys, why do we not? Why do we lower the nose in one crisp movement and then roll the wings level? Why can't we do them both at the same time? Because this is how we teach it with our pattern array. 1, 2. Do we? Did I get that right?
Let's do the rolling G or something.
That's 1, 2. Yeah. No. Low decreasing airspeed. Probably airspeed indicator lagging. What happens to this aileron if I roll?
Increased angle of
Okay, so in that attitude with bugger all airspeed, you're getting slow, getting close to the stall. So what happens to the angle of attack as we do that?
It's going to increase. Could stall that way.
So we might not have the desired effect of that. it might go like that, because that wing might's still very, very important that they do get the correct order and insist on it. And sometimes patter can be, 1, 2. Nose lie, spiral descent. Why do we have to get the wings level before we can raise the nose?
Because there's less distance to raise the nose to the horizon. Instead of going out like that, you're going straight up.
Lift vector is of more use to you here than it is here, the vertical component. Yeah. It's one reason. Another reason, you said before,
Rolling G.
rolling G, the whole VA envelope thing. So what would happen to, if we're rolling that way, what would happen to this aileron
It's going to go down into the wind.
to generate more lift? So now we're increasing the stall speed on this wing, we're increasing the loading on this wing, but mainly the loading, yeah, and that ties in with the rolling G thing, yeah, so, and insist on that, so it's closed throttle, it's 1, 2, 3, closed throttle, wings. Full power, 1, 2, 3. Quite often I'll do an instrument rating and renewals even. And this isn't, don't know if it's not taught properly or probably just not revised sufficiently. One of the things in an instrument rating, as you know, we're going to do unusual attitudes, and I'll get them out of order. So I'm sitting there thinking, oh, you know, but everything's good, but all these unusual attitudes. Yeah, so they need to be right. He's probably two, really, yeah. At the end of the day, there's 1, 2, 3, and 1, 2, 3. That's all we're teaching. If you got this for your sea cat, it'd be a bit of a gift, wouldn't it? How long are we meant to be lecturing for?
Another hour. I think we were meant to go until 11 today.
I don't know what else to do.
Have another coffee.
Yeah. Questions at the end?